Hey there, science explorers. Have you ever noticed that the world is always moving? It's true. From the birds soaring in the sky to the cars zooming down the street, everything around us is in motion. Motion is simply a change in position over time. Motion is super important because it allows us to experience the world around us. Imagine if nothing ever moved. How boring would that be? We wouldn't be able to walk, talk, or even play our favorite sports. Motion is everywhere and in everything. Even things that look still, like the desk you're sitting at, are made up of tiny particles that are constantly moving. So the next time you see something moving, take a moment to appreciate the wonder of motion. Now that we know what motion is, let's explore the different ways things can move. First up, we have translational motion, which is like driving a car in a straight line. The car moves in one direction without turning or rotating. Next, we have rotational motion, which is like spinning a top. The top spins around a fixed point, and every part of it moves in a circle. Then there's oscillatory motion, which is like a swing moving back and forth. The swing repeats the same movement over and over again. Finally, we have random motion, which is like a bee buzzing around a flower garden. The bee moves in all different directions without a clear pattern. Can you think of any other examples of these types of motion? We know that things move, but how fast are they going? That's where speed comes in. Speed tells us how quickly an object is moving. We calculate speed by dividing the distance traveled by the time it takes to travel that distance. For example, if a car travels 60 miles in 1 hour, its speed is 60 miles per hour. Speed is usually measured in meters per second or kilometers per hour. Faster objects travel a greater distance in the same amount of time. For example, a cheetah running at 100 kilometers per hour is much faster than a snail crawling at 1 centimeter per second. Section 4, keeping track of time from sundials to smartwatches. Time is a fundamental concept that allows us to measure the duration of events and the intervals between them. It governs our daily lives, from the moment we wake up to the time we go to bed. But how did humanity's relationship with time evolve over the centuries? But how did people keep track of time before clocks and watches? In ancient civilizations, people relied on natural phenomena and simple tools to measure the passage of time. One of the earliest timekeeping devices was the sundial. Sundials were used by ancient Egyptians and Greeks, and they were a common sight in gardens and public spaces. Sundials work by using the position of the sun in the sky to cast a shadow on a marked surface. The shadow's position would change throughout the day, indicating the time. As the sun moves across the sky, the shadow moves as well, indicating the time. However, sundials were limited by weather conditions and the time of year. Another ancient timekeeping device was the water clock, which used the flow of water to measure time. Water clocks were used in ancient Egypt, Greece, and China. Water clocks were more accurate than sundials, but they were still not perfect. They required constant maintenance and were affected by temperature changes. Over time, people developed more accurate and sophisticated timekeeping devices, such as mechanical clocks, quartz clocks, and atomic clocks. Each advancement brought us closer to precise timekeeping. Today we have digital clocks and smartwatches that can tell time with incredible precision. These modern devices not only keep us punctual but also offer a range of features, from fitness tracking to notifications, making them indispensable in our daily lives. Section 5. Tick-Tock goes the pendulum. A pendulum is a weight suspended from a fixed point that swings back and forth under the influence of gravity. But did you know that pendulums can also be used to measure time? The time it takes for a pendulum to complete one full swing is called its period. The period of a pendulum depends on its length. Longer pendulums have longer periods and shorter pendulums have shorter periods. Pendulum clocks use this principle to keep time. The pendulum swings back and forth, and a mechanism in the clock counts the swings and translates them into hours, minutes, and seconds. Section 6. Motion pictures, deciphering distance time graphs. Graphs are powerful tools that help us visualize and understand data. They provide a clear and concise way to represent complex information, making it easier to interpret and analyze. In science, we often use distance time graphs to represent the motion of objects. These graphs are essential in understanding how objects move and change position over time. A distance-time graph plots distance on the vertical axis and time on the horizontal axis. This setup allows us to see the relationship between the distance an object travels and the time it takes. The line on the graph shows how the distance traveled by an object changes over time. By examining the slope of the line, we can gain insights into the object's speed and movement patterns. A straight line on a distance-time graph indicates that the object is moving at a constant speed. This means the object covers equal distances in equal intervals of time. The steeper the line, the faster the object is moving. A steep slope indicates a high speed, while a gentle slope indicates a slower speed. A horizontal line on a distance-time graph indicates that the object is at rest, meaning it is not moving. This can be useful in identifying periods of inactivity or rest in an object's motion. By analyzing the shape of the line on a distance-time graph, we can determine the speed, direction, and even the type of motion of an object. This makes distance-time graphs a valuable tool in both education and practical applications. Section 7, Motion, Speed and Time, the big recap. In this journey through the world of motion and time, we've learned that motion is all around us, from the smallest particles to the largest celestial bodies. It's a fundamental aspect of our universe, influencing everything we see and do. We've explored different types of motion, from the straight-line motion of a car to the oscillatory motion of a swing. Each type of motion has its own unique characteristics and laws that govern it. We've discovered that speed tells us how fast an object is moving, and that timekeeping has evolved from ancient sundials to modern atomic clocks. These advancements have allowed us to measure time with incredible precision. We've even learned how to decipher the secrets of motion hidden within distance-time graphs. These graphs are powerful tools that help us understand and predict the behavior of moving objects. So, the next time you see a bird in flight, a car speeding down the highway, or even just the second hand on a clock ticking by, remember the fascinating science of motion and time that governs our world. These everyday occurrences are all part of the grand tapestry of physics. Keep exploring, keep questioning, and keep the spirit of scientific discovery alive. The world is full of wonders waiting to be uncovered, and your curiosity is the key to unlocking them.